Hello, good morning to all of you. I am Pradeep Singh. I am going to start here the lecture series on the topic pump. As far as this topic is concerned, this topic is very important for any interview or for any examination. Before starting this lecture series, I would like to share some information. What are the lecture outcomes? Means lecture outcomes means after watching these lectures you are able to learn about how the pump, what is the pump, what is the working principle of the pump, and how can we calculate the work done by the pump, how much work is done by the pump on the fluid, basically liquid. And also we are able to know the concept of NPSH, cavitation, and some numerical problems as well. Through numerical problem we will able to also grasp about the practical approach. So we are able to learn each and everything about the pumps. So this lecture series will be very important, and you must watch these lectures before going up here into any interview regarding the chemical and mechanical engineering. So my dear student, first of all you must know what is the function of pump. So basically pump is a device which used to transport the liquid from one location to other location. It is a transportation devices. Means pump is a device which used to transport the liquids from the one location to other location. That is a function of pump. You can also define the pump in another way, like pump is a turbo machine. Pump is a turbo machine which imparts the energy to the fluid, which imparts energy, which adds energy to the fluid. So before this we also must know ki what is turbo machine. So first of all, what is a pump? Pump is a device used to transport the liquid by adding energy to it. Okay guys, now, or you can also say pump is a turbo machine. Pump is a turbo machine which adds or imparts energy to fluid so now the new word has come here, it's turbo machine. Okay, so pump is a type of turbo machine, means pump is a sub part of turbo machine which adds or imparts the energy to the fluid which helps in transportation. Clear beta? So we can also define turbo machine as the first of all we must know what is turbo machine. Turbo machine is a device in which energy transfer occurs or takes place between flowing fluid between flowing fluid and a rotating element due to dynamic action, which results in means when the machine, which is a device which either add or remove. Why? Because we are talking about energy transfer between. So energy can be transferred between the flowing fluid and the rotating elements, either by element to the flowing fluid or from flowing fluid to the rotating element. Both is possible. Clear beta? So turbo machine is a device which can either add the energy to the fluid or it can extract the energy from the fluid. Both is possible. Okay, and when it happen, then that results in what? Change in the pressure and momentum of the fluid, which results in a change in pressure and momentum of the fluid. So when these things happen, when the energy get transferred either to the fluid or from the fluid, then which results in change in the pressure and momentum of the fluid. When energy get added to the fluid by the rotating devices, by rotating elements, then obviously energy of the fluid out will be more than the energy of the fluid in. So on the behalf of this, turbo machine is of two types: one which adds the energy and which extracts the energy. So which adds energy to the fluid that is pump or compressor. Pump and compressor. Pump or compressor are types of turbo machine which adds the energy to the fluid. It means if it is a either pump or compressor. Compressor are used for the gases, to transport the gases, while pump is used for liquids to transport. This is what E dot in and this is what E dot out. And in this case I told you energy has been added. It's in terms of shaft work, WSH. So obviously since energy has been added, energy will get added to the fluid by the rotating devices. That's why the energy out is more than energy in by the amount of energy which has been transferred to the fluid. Yes or no? In the ideal case. Otherwise in the real case what happens? Obviously whatever the energy has been transferred to the fluid through shaft, all will not get transferred. Some of them will get utilized in removing the friction and all. So that is different thing. But in general, E here, E dot out is more than E dot in. Clear? So this is what the turbo machine. And second type of turbo machine is called as turbine, which extract energy, which extract energy from fluid. and that is turbine. Turbine is a type of turbo machine which extract the energy from the fluid. Here E dot in, E dot out. Energy has been removed in form of shaft work, and hence here obviously E dot in is more than E dot out by the amount of energy which has been removed out. Clear? So this is about turbo machine, and that's why I've told you कि pump is a type of turbo machine which add or impart the energy to the flowing fluid through a rotating element, which results in increase in the pressure energy or increase in momentum, because when energy will get added, the momentum or pressure energy will get changed, and the change in form of there is increase is there when I'm talking about the pump. Clear beta? Now classification of the pump. Pump can be classified on behalf of its working principle and its mode of action. So here I am going to classify the pump as a basically in two major parts, that is called as dynamic pump and here positive displacement pump. Okay, as far as dynamic pump, also called as dynamic pressure pump, there is example of dynamic pump is centrifugal pump, which is our center of attraction. Centrifugal pump. And in positive displacement pump there is another two classification. One is reciprocating pump and rotary pump. Reciprocating pump and rotary pump. In reciprocating pump there is a pump is like piston pump and diaphragm pump. Piston and diaphragm. In rotary pump there is example like gear pump, low pump, screw pump, vane pump, peristaltic pump, peristaltic pump. So this is what the classification on the behalf of their working principle. So which pump I am going to start in more detail, that is the dynamic pump, and example of dynamic pump is centrifugal pump. So first of all we must know what is dynamic pressure pump. In dynamic pressure pump, basically during pumping action or during transfer of energy to the fluid, tangential force is imparted which accelerate the fluid. So through which force tangential force is going to impart? By the centrifugal action. Or you can say in a dynamic pump basically we are going to add the energy to the fluid by centrifugal action. And when the centrifugal force is going to apply on the fluid, that will increase the velocity or increase the kinetic energy of the flowing particles. Clear? So dynamic pump are, so basically as far as classification, or you can say as far as the definition of dynamic pump is concerned, dynamic pump is a type of velocity pump in which the kinetic energy is going to added, kinetic energy is going to increased. How it is possible to increase the kinetic energy? By the centrifugal action through impeller. Okay, so basically dynamic pump is also called as rotodynamic pump. I am going to write here dynamic pump. It is a type of velocity pump in which kinetic energy is added or increased to the fluid by increasing the flow velocity through centrifugal action. Clear? And whatever energy has been increased, listen, in dynamic pump whatever energy has been increased through centrifugal action, whatever kinetic energy has been increased through centrifugal action, that energy is converted again into the pressure energy. Okay, so this is what the definition of dynamic pump. Now, and the example of dynamic pump is centrifugal pump. Okay, so basically first of all we know what is centrifugal pump. The centrifugal pump is a type of dynamic pump which increase the kinetic energy, or which converts, basically the main function of centrifugal pump is first to increase the kinetic energy, and then that increased energy has to be converted to pressure energy. In one line you can write the centrifugal pump is a pump used to increase the kinetic energy of flowing fluid through centrifugal action, and then increased energy, and then this increase is energy is converted into hydraulic energy or into pressure energy. So basically it is used to convert the mechanical energy into hydraulic energy, and mechanical energy is kinetic energy. So in short you can say it is used to convert the kinetic energy into hydraulic energy, or you can say pressure energy, or mechanical energy into hydraulic energy, which is the pressure energy. How it is possible to convert? The first, this pump through centrifugal action, it will increase the kinetic energy or mechanical energy by increasing the velocity, and then whatever energy has been increased, that energy has to be converted into the pressure energy or hydraulic energy, also called as pressure energy. It is clear? This is what the centrifugal pump does. Clear? The main function of centrifugal pump is to convert the kinetic energy into the pressure energy. So this is what the centrifugal pump. So centrifugal pumps, basically it is used to pumps the liquid by means of centrifugal force developed by rotation of the impeller. So what are the major components in the centrifugal pump? Obviously there should be a impeller, है ना? And that impeller should be mounted on a shaft, and that impeller which mounted on a shaft should be enclosed in a casing, and in the casing should be attached with the suction pipe and discharge pipe. Yes or no? So as far as the pump is concerned, because we must know what are the major components in the centrifugal pump, and what is its view, that I am going to discuss here. First of all, there is a shaft is there. Here, this is what the impeller. Basically, wait. So they are impeller. Okay, this is what the impeller is there. All the impeller is of different type that I will discuss later on. Now this impeller is mounted on a shaft. This shaft is also called a center or eye of the impeller. It's mounted on a shaft, and this is called a eye or center, eye of impeller. And here there is also an guide vanes or diffuser. What is the role of guide vanes and diffuser? I will discuss it. This is what sorry this is what guide vanes. This is guide vane, also called as stator, and this whole arrangement enclosed in a volute types of casing. What is the volute casing? Just wait. Casing is of increasing area is called as a gradual increase is there in their cross sectional area. This type of casing is called volute casing. Here discharge, and this pipe is called discharge pipe. And where is the suction pipe? Suction pipe is just here. Suction pipe is attached, means liquid come. What is working principle? Listen, first of all, just try to understand what are the. This is called a volute casing. VOLUTE, volute casing. So this is the cut section, and I told you कि centrifugal pumps used to pump the liquid by means of centrifugal force developed by the rotation of the impeller. So this impeller, this red, which has been shown by the red color, impeller is mounted on a shaft, and as the shaft rotates through the electric power, through electricity, the shaft impeller mounted on a shaft, and the impeller will also get rotate. Okay. and this is the direction of rotation here. This is the direction of rotation. So as the impeller rotate, then obviously it creates the low pressure zone at the center, and as the impeller rotates, and first of all you must know कि first of all liquid should be in the contact. As the liquid come at the eye, liquid come directly here at the eye of the impeller, means first liquid come to the eye of the impeller, and as it liquid come into contact with the rotating impeller, it imparts the energy, it adds the energy, because as soon as the liquid come in the contact, as soon as the liquid come at the center of the impeller, how liquid is able to come, that I will discuss later on. But let's say कि as the liquid come to the eye of the impeller, is thrown readily outward, my dear student, है ना? Why? Because of centrifugal action. So due to centrifugal action, the liquid thrown readily outward. So obviously that centrifugal action via impeller, the kinetic energy has been increased of the fluid. Clear? That's why I told you कि in the centrifugal pump is used to increase the kinetic energy through centrifugal action, and then this increased kinetic energy has to be further converted to pressure energy. So how this conversion is possible? The first you have seen कि as the liquid reach to the eye of the impeller or center of the impeller, it thrown readily outward because impeller is rotating with high speed, and it creates centrifugal action, and due to centrifugal force action, the liquid particles thrown readily outward, and as the liquid particles move outward, you have seen the area for the flow increases. Impeller design is such that you can see carefully. If I am going to exaggerate any one of the impeller, let's say I am talking about this impeller only. So impeller's design is like this. So this is what the eye of the impeller, and this is, let's say, A point, this is what the B point. So as liquid come, because of centrifugal force, the liquid thrown readily outward. So as liquid come out through the center of the impeller, it has high kinetic energy. But as liquid passes through the increased area of the vanes, because impeller design is such that area for the flow increases, then you know A1 V1 equal to A2 V2. Or you can say area into, from the quantity equation, area into velocity is constant. As the area for the flow get increases, then velocity get decreases. And from the Bernoulli principle, the sum of kinetic energy, pressure energy and potential energy remains constant along the streamline. Yes or no? So as I told you, since AV is constant, the two concepts I am going to use here, one is continuity equation and other is AV is constant, and other is Bernoulli equation, P plus half rho V square plus rho Z Z equal to constant. Clear? So this sum of three energies should be always constant from the Bernoulli principle. So what happened, as the fluid released from the center of the impeller with high kinetic energy, velocity get increases. So as it passes from A to B, the area for the flow get increases, then velocity get decreases. It means kinetic energy will get decreased, and that decrease in the kinetic energy results in increase in the pressure energy. So this is how there is a conversion of kinetic energy into the pressure energy or hydraulic energy. Clear? So as far as the point A and point B is concerned, at the point A, the fluid liquid particles have high kinetic energy but low pressure energy, but at point B the fluid have high pressure energy and low kinetic energy. So whatever kinetic energy has been increased through centrifugal action has to be converted into the pressure energy because of increasing area. Then again, all of the increased kinetic energy cannot be converted into pressure energy in that part. That's why rest of the increased kinetic energy, has to be further converted into the pressure energy through guide vanes or through stator. What is the function of stator? Stator provides again increased area, and it will make the fluid to nearly stop. I'm not saying completely stop. And when the fluid, when this stator or guide vanes makes the fluid to nearly completely stop, then obviously the kinetic energy will drop immediately, and that kinetic energy is conserved. That kinetic energy is going to further convert into pressure energy. Then again, as point B and point C is concerned, now let's say the C point, the liquid which released from the point C will obviously have more pressure energy as compared to point B, because of again area for the flow get increases, and it will reduce the velocity. Also it will make the fluid to nearly stop. Nearly stop means it's not completely stop, it means it's just a provision for the conversion of further kinetic energy into the pressure energy. Okay, and when the liquid release from this that have high pressure energy, and again the design of casing is volute casing. Volute casing is the casing of with gradual increase in the cross sectional area. What is meaning of volute? Volute means any shape which have increased surface area, increased cross sectional area, that is called, not surface area, increased cross sectional area, that is called volute. So here the casing is a volute type. It means in these types of casing the area for the flow gradually get increases. Then as the fluid flows through this here, then obviously it's again flow through the increasing area. As the area get increases, again the velocity get decreases, and that decreases the velocity will also increase in the pressure energy. Then ultimately when the fluid released from this will have high pressure energy and low kinetic energy. Clear beta? So this is what the working principle of centrifugal pump. So first of all you should write the kinetic energy imparted to the liquid by impeller rotation is converted into pressure energy by making the liquid to flow through first through impeller, second through diffuser, and then through volute casing. Clear beta? So when the fluid passes through impeller, diffuser and volute casing, in that the energy which has been increased through the impeller is going to convert into the pressure energy. Clear? Any problem beta? So first of all, as far as working principle, again listen. Liquid enters the pump through the inlet connection. There is an inlet pipe is there, suction pipe also called. So liquid enters the pump through suction pipe at the eye of the impeller. Okay, impeller rotates and imparts the energy to the liquid and deliver it at a higher velocity to the diffuser. In the diffuser, the velocity energy or kinetic energy is converted into the pressure energy. The volute completely surrounds the diffuser and serves to collect the liquid and to recover the additional velocity energy into the pressure energy. And liquid ultimately then get discharged. This is what the working principle. Clear beta? So in short, in the point you can write some 1 or 2 3 point. A liquid enters the pump through the inlet connection and enters the eye of the impeller, enters to the eye of impeller. Second point, The impeller rotates and imparts energy to the liquid and delivers it at higher velocity to the diffuser. In the diffuser, kinetic energy is converted into pressure energy. Clear? The volute completely surround the diffuser and serves to collect the liquid and to recover, and also it acts to recover kinetic energy into pressure energy, and then liquid get expelled. Clear? So this is what the working principle. In some of the centrifugal pump you will not found the diffuser or guide vanes. Guide vanes also called as diffuser or diffuser. So main purpose of diffuser is to maximum conversion of kinetic energy to pressure energy, है ना? So if you want to have a high performance from, if you want to expect the high performance from the centrifugal pump, then obviously we have to place the diffuser where high performance is required. Then we should add the diffuser, because diffuser is used to convert the most part of the kinetic energy into the pressure energy. Okay. Otherwise, in general, in a simple pump that we use in our household, there is no diffuser is there. There is only impeller is sufficient. Impeller and volute casing is sufficient. Huh? So depend upon the requirements, we can also add the diffuser and guide vanes. Okay. Any problem? So this is what the working principle of centrifugal pump, which is the dynamic pump. Now the other question is that how much work is done, or work done by the centrifugal pump on the fluid which are going to transport. So in order to calculate work done by the pump, we have to write the Turbomachine equation, and this is basically the angular momentum equation. Although here the phenomena is very complex, but still we can simplify this phenomena of energy transportation or energy calculation through the velocity triangle diagram. So that I will discuss in the next lecture, but before this I would like to discuss here how can write the energy balance over the pump. Okay. As far as energy balance over the pump is concerned, this is what the centrifugal pump we are used to. We are used to represent the centrifugal pump like this. This is what the suction pipe. In general, suction pipe diameter is larger than the discharge pipe. Why it is so, I will all discuss in the subsequent lectures. So this is what the centrifugal pump is there, and this is what, let's say, 1 point, and this is the 2 point. You can also draw in this way. ठीक है. 2. One point is the suction point and second point is the discharge point of the centrifugal pump, and all the impeller and stator are inbuilt in that casing. ठीक है बेटा. So this is how I can represent the centrifugal pump. So as far as energy balance is concerned, we can write the energy balance between the 1 and 2 point, and that is what P1 by, before this is energy has been added through shaft in form of shaft work, WSH. This is called as shaft work or power. Shaft power you can also say. POWER, shaft power. WSH is the shaft power, and that is unit is kilowatt or watt, because unit of power is kilowatt or watt. It is shaft power. The shaft power is the power which has been added to the shaft of the pump through electric power. Now we can also write the shaft power in terms of per unit mass, because as far as kilowatt is concerned, this is also you can write kilojoule per second. And if we divide this shaft power per unit mass flow rate of the fluid, per unit mass flow rate of the fluid, that is become small w s, and dot will not be there because it will not be rate now. It's simply energy per unit mass. How you can say, because as far as this is concerned, it's kilojoule per second, and when I divide by kg per second, it's mass flow rate, then second cancel out, it simply become kilojoule per kg. So my dear student, ws is simply called as energy transfer per unit mass of the fluid. Capital WSH is the power, small ws is the energy transfer per unit mass of the fluid. Clear? So this is the notation that we are going to use here. So as far as energy balance between the suction point, which is 1 here, and discharge point 2 is there, is concerned, we can write the energy balance in terms of energy per unit mass. In terms of energy per unit mass, in terms of energy per unit mass, you know Bernoulli equation P1 by rho, but in the Bernoulli equation one energy should be added, that is called as shaft power, that we are going to add here. So what is the total energy of the fluid at point 1 is there? Total energy is sum of pressure energy, kinetic energy and potential energy. So that energy P1 by rho plus V1 bar average velocity square by 2, and ideally we should write the kinetic energy correction factor, but we are going to assume the flow is highly turbulent, that's why kinetic energy correction factor is 1. So P1 by rho plus half V1 square by 2, it's again per unit mass, plus ZZ1 plus energy which has been, because this is the energy of the flowing fluid, and my dear son, WSS is the energy which has been given to the shaft. So energy that is given to the shaft will not transfer to the fluid as a whole, completely will not be added, because you know very well there is a mechanical, because energy is transferred to the shaft via motor, and there is always some mechanical losses are there, you know, to overcome the frictional, to rotate the bearings and all. So we can't ignore this. That's why whatever energy has been supplied to the shaft, all will not transfer to the fluid. Is this clear? So since here I'm talking about this is the energy at point 1 to the fluid, of the fluid. So in this case what we are doing, we are also going to add the energy through shaft, and I'm going to add W efficiency into small ws. Small ws, why? Because every term is energy per unit mass, and this is ws energy per unit mass. Is this clear? And why efficiency is there? Because all energy is not going to transport to the water, because whatever energy has been transferred to the shaft to the motor, then if we are going to transfer WSH, then it's providing less than this. WS is less than WSH, है ना? So as a whole, this is actually the energy which has been transferred per unit mass of the fluid to the fluid via pump. Okay beta, and that is equal to P2 by rho plus V2 bar square by 2 plus G into Z2. This is what the energy balance. Any problem? And my dear student, it's nothing. That part is the total energy E1 dot. Now I told you na in the starting ki E1 dot, and this is what E2 dot, and E2 dot is more than E1 dot by the amount of WSH. E2 dot minus E1 dot is equal to WSH, which has been added. Because we are going to add the energy, that's why energy at the outlet is more than energy at the inlet. Is this clear? So since if we divide the whole equation by if we divide the whole equation by, this is simple energy balance. If we divide the whole equation by the mass flow rate of the fluid, by the mass flow rate of the flowing fluid, then E2 by this equation, I would like to write this as a main equation. In simple balance, you should write E1 dot minus E2 dot minus E1 dot is equal to WSH dot. If we divide the whole equation by mass flow rate of the flowing fluid, and we should also add efficiency. Why? Because all shaft power is not transferred to the fluid, only some part of that. That's why efficiency is multiplied. Then this implies that small e2 is energy per unit mass. Small e2 minus small e1 equal to efficiency into small w s. Clear beta? This is what here, and this also implies that E1 plus efficiency into small ws is equal to E2, and this is what I have written here. This is small E1, this is what is small E2, and this is what efficiency into ws. Is this clear? So E2 is more than E1 by the amount of energy which has been transferred to the fluid per unit mass. So unit is balanced here. It's all about energy per unit mass. Clear? In short, you can also write efficiency into ws is equal to P2 minus P1 by rho plus V2 bar square minus V1 bar square by 2 plus G into Z2 minus Z1. So, and as far as potential energy is concerned or kinetic energy is concerned, this term is very negligible, because if you talk about, this is what the potential head difference between the 1 and 2 point, which is very small. Potential head difference is Z2 minus Z1 here, and the potential head difference Z2 minus Z1, it is very small as compared to the other two. Then what is the physical significance of this equation? As far as physical significance is concerned, this is nothing, it's energy which has been added to the fluid per unit mass. Added to the fluid, not to the shaft. Shaft is ws, but when I multiply with the efficiency, then it's energy added to the fluid per unit mass of the mass flow rate of the fluid. That energy is utilized to increase the pressure energy and increase the kinetic energy. And if suction and discharge pipe is of the same diameter, if the suction and discharge pipe is of same diameter, then V1 equal to V2 from the continuity equation. If suction and discharge pipe is of same diameter, then from the continuity equation A1 V1 equal to A2 V2. And if the suction and discharge pipe is of same diameter, then obviously we can also ignore the, then in short we can write Ws is approximately equal to what? P2 minus P1 by rho. It means whatever energy we have added, that is used to increase the pressure across the pump. So this is what the rise in the pressure across the pump means. P2 is more than P1. Is this clear? So this is the energy balance we have written in terms of per unit mass. Is this clear? Any problem with this? And in general, the kinetic energy change and the potential energy change are very negligible, then we can ignore this. But if the suction and discharge pipe is of different diameter, then we should also write the kinetic energy term. Clear beta? So it's simple energy balance is there. Okay, whatever energy we have added to the fluid, that will either increase the pressure energy and increase the kinetic energy and increase the or change in pressure energy, change in the kinetic energy, change in the potential energy. Potential energy change is negligible, and change in the kinetic energy can also be ignored. If suction and discharge pipe is of the same diameter, it will become 0. But this P2 minus P1 can never be 0, because whatever energy we have supplied, that is mostly used to increase the pressure energy of the fluid. So sometimes in the exam, in the question, they used to ask uh, what is the pressure rise across the pump. The pressure rise across the pump you can calculate from this equation as a delta P is the pressure rise across the pump, and that is nothing efficiency into Ws. Ws is nothing energy transfer per unit mass into density of the fluid. Yes or no? When we multiply with density, I got the pressure drop rise or pressure drop across the pump. Clear? Now this is what in terms of we have written energy balance per unit mass of the flowing fluid. We can also write energy balance in terms of energy per unit weight of the flowing fluid, and whenever we will write the energy per unit weight of flowing fluid, that is in terms of head, because energy per unit weight have a unit of length. Okay, now the second balance I am going to write here, energy balance in terms of per unit terms of head. And head is nothing. What is head? My dear, head is energy per unit weight. Energy per unit weight of the fluid. Energy, previously we have written energy per unit mass, now we are going to write energy per unit weight of the fluid. So again, the fundamental is same. This is what the suction pipe, this is what the discharge pipe. It's 1 here, is 2 here, and we have added energy in power is WSH, and again E1 dot or E2 dot, E2 is more than E2 dot minus E1 dot is equal to WSH. It's energy balance. When I divide the whole equation by mg, m dot g, so when I divide this, every terms, whenever energy per unit weight of the fluid has a unit of head or unit of length, that's why it's called as head. ठीक है बेटा, तो we should write here H2 minus H1 is equal to, I can write as a here efficiency should be also right, efficiency into I should write here HS, energy added to the shaft in terms of head, HS. ठीक है बेटा, so this is what energy balance in terms of head. And what is H2 is there. If you apply now, if you apply the Bernoulli equation in terms of head, this is P1 by rho g. This is P1 by rho g is the unit of head. It's energy per unit weight of the fluid, plus V1 bar square by 2g plus Z1, again it's in head, plus efficiency into HS that we have added is equal to P2 by rho g plus V2 bar square by 2g plus Z2. Okay, my dear student, and this is nothing, this term is actually H1, total energy in terms of head. This is what H2, total energy in terms of head at exit. Again I got the same H2 minus H1 equal to this. Clear? So efficiency into HS, HS is nothing, energy added to the shaft in terms of head, and efficiency into HS is the energy added to the fluid in terms of head. Okay, this is what P2 minus P1 by rho g plus V2 bar square minus V1 bar square by 2g plus Z2 minus Z1. And again I told you the change in the potential energy is very small, I can ignore, and if suction and discharge pipe have same diameter, that can also be ignored. Then efficiency into HS is nothing, it's approximately equal to P2 minus P1 by rho g if suction and discharge pipe is of same diameter. Otherwise we should also write the kinetic energy. So what, this is equation number 2. Equation number 1, that is energy this is efficiency into HS is the energy added to the fluid in terms of energy per unit weight of the fluid. So what is difference in these two? Difference in HS and small ws is what? My dear student, ws is power per unit weight of the fluid, sorry, power per unit mass of the fluid, and HS is power per unit weight of the fluid. Yes or no? Then if you divide these two equations, you can find the relationship between these two. So what are the relationship is there? It means, can you say, my dear student, when I divide, when I am G into HS, G into HS is what? It's WS. Can you say? And when we want to find the power, listen, WS and HS. HS is the energy per unit weight of the fluid, and this is also energy per unit mass of the fluid. So this is what the relationship in two forms of energy in two different units. And how can find that power? WS dot is nothing M dot into WS, and this is M dot G into HS also. So MGH is actually the potential energy, or you can say it's a, basically this is the relationship between the power and head which has been developed by the pump. So HS efficiency into HS is the total head or energy per unit weight of fluid which has been developed by the pump. Clear? So this is what the energy balance we have written. But also we can calculate this power of work done by the pump to the fluid in terms of design parameters. Also I will discuss in the next lecture, and then I will couple these things. Clear beta? Any problem? So you must keep in mind these things. This is the first lecture of the series. I will take 5 to 6 lectures. In the 5 to 6 lectures you will able to learn each and everything. Thank you.